Hey everyone, welcome to Solidworks Live Design. Hey, this is our first episode of the 2023 year. If you're with us for the first time today, be sure to hit subscribe on the Solidworks YouTube channel. And later on, if you learn anything from Adam's presentation, which I'm sure you'll learn many things, hit like once we've earned that from you. So last year with Solidworks Live Design, we made some pretty special changes that will surely continue into 2023. That is bringing on community members to show off their favorite SolidWorks tips and tricks, as well as their creations. And with our first episode here, we're already doing things differently by releasing this episode as a YouTube premiere. That's right, we're premiering a 3D Experience World session before 3D Experience World even happens. Each year, thousands of us get together in person to take in the best SolidWorks technical content in person at World in one location. And this year, it's in Nashville, Tennessee. And if you're watching here in January, it is not too late to register and attend. Hey, if you're unable to attend though, we will have some technical sessions online as well. And one of those will be delivered by Adam here, who works at GoEngineer. And I have some questions for Adam that we'll go through to provide some context for his session and the content overall. And if you have questions, be sure to ask them in the YouTube live chat or in the comments area. We'll be watching along live with you, ready and waiting for your comments. And with that, I'd like to welcome on Adam Lundgren. Adam, how's it going, man?
Hey, Sean. It's going pretty great. Just excited to be here.
Yeah, man. Happy to have you. Welcome to the first episode of Live Design for the year. So just first question, if you could tell the attendees, who you are and what you do.
Yeah, so I'm an applications engineer at GoEngineer. As you mentioned, my name's Adam Lundgren, and GoEngineer is based in Salt Lake City. That's where I'm at. So basically what an applications engineer does is as other engineers are working with SolidWorks, it's my job to especially fix the knowledge within other people. We do have tech support that fixes SolidWorks in general, but when I have engineers that come and say, "Hey, I don't know why it's doing this. Can you help me out with that?" Sure. It's my job to help them fix that knowledge.
Awesome, man. Yeah, I was in some ways I'm still an application engineer. And I used to work at a partner out in the other end of the United States, and that a lot of what you mentioned is my favorite part of the job. And another favorite part of our job was the ability to participate in 3D Experience World, which used to be called SolidWorks World, right? And I know that SolidWorks is near and dear to both of our hearts. Have you been to 3D Experience World before? And I guess if so, how many times?
So I can say for myself that this will be my first time actually physically attending.
Awesome.
But last year I did watch some sessions, and working at GoEngineer, I've bumped shoulders with plenty of others that have talked up 3D Experience World quite a deal. So I am quite excited. This will be my first, and I'm excited to attend.
That's really cool, man. So what are you most looking forward to about attending in person for the first time?
Well, like I mentioned, having been at GoEngineer, I've been with people that go every year, and this will be no exception. I'm going to be going with a lot of other people, and the caliber of expert that I've seen that are attending, let alone presenting, makes me very excited to be around these type of people to see what knowledge I'm going to learn, and hopefully what knowledge I'm going to give.
Absolutely. I think you might feel the same. I remember when I worked at a partner, one of my favorite things to do is actually go to the user breakout sessions. For those of you who don't know, our partners, we have our own partner sessions, as well, but love going to the user breakout sessions because you just kind of learn so much, right? You learn, it's like, how are you doing this out there in industry? And, you kind of learn as well, like who were some of the biggest voices, the greatest minds in the SolidWorks community. So that's really great. And when I saw that your session was going to be presented and available, I was super excited. We just did the SolidWorks 2023 What's New episode on YouTube, which for a time at least was like the highest streamed episode of SolidWorks Live. It's been unseated by the simulation episode we did late last year. Actually, just a couple of days ago, it was unseated. But what made you want to create this session, which of course is about repairing mates in assemblies, and what are some of the key takeaways that you baked into it?
Yeah, so talking about the What's New 2023, a few months ago, that's what all the VARs were doing, myself included. I was presenting, these are the things that are new in 2023. And when I saw this, I used to work in luxury goods industry, and I worked on large assemblies. And mates were breaking, a bit as parts were updated and
Sure.
things changed. Yeah. And so a big part of my job was to fix that. Well, having experienced that, and I saw auto repair mates and what's new for 2023, I got very excited. And of course, when I was approached by SolidWorks saying, "Hey, we'd like everybody to submit what you'd like to do for 3D Experience World if you wanted to try to present," I thought, well, hey, this seems like a good idea. Let's go for it. As it turns out, as I was going through and making the idea and trying to move forward with it, I was looking at other people's what's new videos that were popping up on YouTube. And I was actually finding that this was actually seldom talked about. And so it just made me all the more, I guess, convicted would be the right word to say, okay, I'm going to really try to, or yeah, I think convicted's the right word, to try to push this forward and talk about this, because this can be huge for some people.
Awesome. Yeah, absolutely. You go through so many enhancements during the course of a what's new season, right? And we're all, you and myself, like we're all just trying to make sure that our customers, right, the audience, like we all see the value. And of course, we're tech people. We're really excited to get this stuff out to the masses, but you don't get to focus so much on each individual enhancement, which is kind of a shame. But you see like the audience, whether it's virtually or in person, they're like, yeah, like auto repair mates. Nice vignette, nice little video, nice pick and click you did there. I can't wait to get back to the office, install 2023, and try it out for myself. And we get to explore that further with your session, which we're going to show in just a moment here. But hey, Adam, before we go, is there anything else that you wanted to shout out?
Well, I mean, I made this presentation for all the engineers that are working on all those assemblies. So I guess it'd be a shout out to them. And hopefully you'll learn some tricks that in 2023 will make your life easier, and some other tricks that will apply to all of the SolidWorks versions that'll hopefully make your assemblies break a little bit less.
That's a great intro to the session. But thank you so much. So, all right, everyone, Adam and I will be monitoring the chat and the comments area after the stream. Once again, be sure to ask any questions you have and head out to 3dexperienceworld.com to register for the event today. Thank you so much, Adam.
Thank you. Hello, and thank you for tuning in to my presentation at 3D Experience World, making use of Auto Repair Mates function. This was something new in 2023 that I'm super excited about the potential save time for many people in all industries. My name is Adam Lundgren. I'm an applications engineer at GoEngineer, and I've worked in the luxury consumer goods industry before joining the VAR channel. I have obtained my certification for SolidWorks Expert in Mechanical Design, and have been using SolidWorks for over half a decade. I've worked on various complex assemblies, from drones to jetted hot tubs. Assemblies are the main reason why I got so excited about this new feature, and why I'm pleased to share it with you today. In one of my past jobs, it was common for over 20% of my work week to be spent updating mates on extremely large sub-assemblies and assemblies. And this feature would have saved me a lot of time then. So I'll be talking about how one uses Auto Repair Mates first so that we can know what it does. Then I want to explain how it does what it does. Once we know this, we can discuss the things that it cannot do, or rather, things that we do to an assembly that make Auto Repair Mates function less automatically. Following this, I'll show you an example assembly that has undergone some revisions to show off the power of this tool. For the last section, let me paint a picture. If broken mates are as annoying as a sunburn, then I am overjoyed with the aloe vera that Auto Repair Mates provides. However, we would ideally apply the sunscreen of best practices to avoid broken mates from happening in the first place. I'll be showing you what some of those might be and how those are done. I believe one of the most common ways many people learn is with examples, so you'll find that I've littered this section with examples. Let's start with one right off the bat. Before we actually talk about using auto repair mates, let's discuss the current state of affairs with mates in Solidworks. I have this moto knee and foot prosthetic limb that I've been working on. Let's say we've communicated with an outside source regarding optimization to a component in the foot. We want it to handle some load, but also be as light as possible. They have returned with a file, though it looks like a step file of the edited part. They said that very few changes were made, and it looks like the general geometry of the foot has remained the same. We want to verify fit and function within our assembly, so let's try and replace the part here. Lo and behold, there are many mates that have failed to locate a reference. Our options here are either we fix the references here in the replace component command, or we go into the mate manager later and replace the missing references one by one. There is some hope that we can eliminate some tedium though. There is a neat feature SOLIDWORKS has already got for us. When we replace the reference for this concentric mate, notice that SOLIDWORKS asks if we want to replace other missing mate references. That is because SOLIDWORKS is already smart enough to realize when a reference we have manually selected to replace a missing one should be replaced in the other mates that are missing that same mate reference. It just hasn't been smart enough to make those selections for us, but that is what has changed with auto repair mates. If I had to go into that assembly and replace each mate, it would take a few minutes, and that is with just one upgraded part. What if you were in charge of that assembly and you were getting updated parts from 4 or 5 people several times a day? You can see how tedious this truly becomes. For some of you, this may be a big part of your job, as it was mine. But that's why you're here, to learn the new and improved, better way. So getting into auto repairing mates, we'll look at an axle with several roller bearings on it. This axle needs to replace all of the inner roller bearings to rubber wheels. In the graphic on this slide, you can see what we want the finished product to look like. When we make the replacement, the concentric mate for the rubber wheel gets broken, so we must go through the process for repairing the mate. Using auto repair mates is as simple as right-clicking the broken mate or the mate folder and selecting the magic button. Let's see that in action. Like I said, we replace the inner roller bearing with the rubber wheel. I want you to take note that the rest of the inner bearings are placed via a linear pattern. This is a best practice that we will come back to later. Now when the replacement is made, we see that the concentric mate for the rubber wheel has failed and needs to be replaced. That's no problem. All we need to do is right-click on that mates folder to use auto repair mates. When we do, there is a magic button on the top of the drop-down. Clicking on this fixes our broken concentric mate and requires no further attention from the user. And that's it. That's how simple it is to use auto repair mates to fix our problems. But now we need to know how SOLIDWORKS just did that. How does it know what reference to select? Each time SOLIDWORKS rebuilds, it recalculates each of the mates that are used to hold the parts in place on an assembly. A face, an edge, or a point is mated together, and each of these entities has an ID. Now if you replace a part or even edit it, it is possible that the entity ID is no longer the same, so SOLIDWORKS loses it. An auto repair mate replaces the missing entity with another by looking for entities that are in the same position and orientation as the missing entity. If there are multiple entities, it will choose one with the same or similar length or surface area, though most of the time it doesn't come to that. After a matching entity is found, it automatically updates the mate that has the missing entity with this new one. If it cannot do this process for whatever reason, some of which we'll discuss soon, it will ask you to manually select an entity to repair the broken mate. Let's look closer at the roller bearing assembly. Since we know that the concentric mate for this linear bearing is the one that fails, we'll look at the faces corresponding to that mate. As we can see, it is a cylindrical face with a diameter of 15 millimeters. Now let's replace that component with the rubber wheel to examine the face auto repair mates will select. Looking at the face we want to replace the previous entity with, it is once again a cylindrical face with a diameter of 15 millimeters. That cylindrical face may have a different surface area, but it was pointing in the same direction and was the same size, so auto repair mates has found it. When we select the repaired mate, we can verify that it did correctly choose the appropriate cylindrical face. It is awesome to see that Solidworks has been made just that much smarter to replace missing references and assemblies. So, we know how it works, but now we need to know some ways that we can make it not work. What breaks this new feature? For one thing, because it's trying to find a new reference based on location and orientation of the previous reference, the new entity must match the previous one nearly exactly. What this means for you is that if you replace a mate and move or rotate the part, auto repair mates will no longer work. Nor will it work if the new reference is different enough that it is either not in the same position or orientation. This actually isn't as bad a thing as it sounds, because I would rather have to manually repair mate than have auto repair mates automatically and maybe accidentally choose an incorrect selection. Otherwise, I have gone through and tested each mate for its compatibility with auto repair mates, and nearly all mates will repair with a few exceptions, and not a single reference was updated with an incorrect replacement. A result of this feature's pickiness is I have found that any mate that is point-to-point has a difficulty being auto-repaired. That is because in part replacement or redesigns, it is very common for points to simply not be in the same place they were previously. Also of note, if you replace a component, auto repair mates will not find a missing reference that is an entire body, which is what's used in lock mates and some mechanical mates. Let's see how picky this feature can be in action. We return once again to this roller bearing assembly. This time, I'm going to move the rubber wheel a little bit after I replace it, and then try to auto repair mates. Notice here, it did not automatically fix the problem. That is because the reference is not in the same position as it was previously. This same problem would occur if we could rotate the part before auto repairing mates. I've noticed for this model that the other mates that define the rubber wheel do it and do it well, and it's just one mate failing. So it may be possible that in this case, if the part was moved a very small amount and wasn't rotated, that auto repair mates will still find the appropriate cylindrical face. And so it does. Let's do a different example. In this case, before I replace the bearings, I changed the diameter of a hole for the rubber wheel by adding an additional millimeter. Now, once again, we replace the inner bearings. As we attempt to auto-repair mates, we see that the mate can no longer be auto-repaired. This is because the reference no longer matches the previous one. It is 1 millimeter in diameter bigger. Again, I do appreciate that it doesn't auto-repair mates on something that is not the same size, because it could lead to incorrect mates being created. But if you are trying to replace a part in your assembly because your machinists say they need the diameter to be a few thou larger, you will need to automatically reattach your mates. And so, because we know how to break auto repair mates, we can take some steps to prevent that breakage, such as not moving our parts before auto repairing that mate. Now we get to explore what the ideal use case would be for this feature, and this is where I'm going to pull in some larger assemblies. We know that mates break when you replace parts or make design changes. When you replace one part with one of similar size, auto repair mates will often do a good job of fixing any broken mates, as we've seen. Similarly, when you make minor part changes, auto repair mates can often find the missing references again. But this is especially useful when you have 100 rivets that are all replaced, or perhaps 20 support beams. Let's say each of those had 3 mates each, 2 of which broke. That's a lot of mates we used to manually fix. What does it look like when we use auto repair on an assembly that has that many broken mates? Now, of course, I've got another larger model that's going to show you an example of this. This is the DTV Shredder full assembly model. This is, as DTV put it, an innovative combination of tank, skateboard, and stand-up jet ski. As we're working on this new project, we might get news that our previous supplier of bolts have, for one reason or another, become unable to fulfill our demand. So we have these new bolts from a different supplier. This supplier has given us a Solidworks model for us to use, and it looks like the head has some slightly different geometry, but the shaft otherwise remains an M5 standard. This doesn't yet have a part number in our system, so for now, we'll call it 461 bolt prototype, as those are the last three numbers in the part number it will replace. When we replace the component for all instances in this assembly, we get the dreaded message that 18 mates have failed. Using auto repair mates is just as easy when one mate fails or 100. When we use that command here, we see that all 18 mates have been repaired. But now remember that moto knee we were working on earlier in the presentation? What happens to that example when we use auto repair mates? Notice again, when we update the old part with the new, that so many of our mates have broken. All I need to do is let auto repair mates work its magic. Because the part with updated geometry has such similar geometry, it is able to replace every single missing mate reference. The only thing we needed to do is suppress a couple of mates that are now making our assembly overdefined, which we would have needed to do anyway. Because of this command, we now have enough time to finish those reports our supervisor wanted yesterday. That is the potential of auto repair mates. The amount of time saved is huge, more time to be put to more effectual use on your projects. Though, as I had mentioned earlier, the best way to fix all your mates is to never break them in the first place. There are a few techniques within SolidWorks that help us to do that. The three ways I would recommend to you to help prevent the need to repair a lot of mates would begin with: first, use replace entities in your parts instead of outright deleting sketch entities. These sketch entities become the entities that we select for mates, so if they get deleted instead of replaced, our mates may lose the references and become broken. Second, we should utilize more subassemblies in our assemblies so that if something breaks, we just have to fix it in one subassembly to fix it all the times in our main assembly. This has the added benefit of generally improving performance in our assemblies. Third, make more use of patterning parts or mirroring in your assemblies. Once again, the goal would be to fix something once and not have to worry about fixing it for all of the other instances when the failed mate would have occurred. This third suggestion was the best practice in use on the roller bearing assembly that made it so that only one mate broke when we replaced the rubber wheels instead of one mate per rubber wheel. But let's take a look at this grill assembly to see another example of why these best practices matter. This front control panel piece has a couple sets of holes for valve control knobs. Now we want to make a design change and shift those holes half an inch lower on the panel. When we open up the part and start editing the sketch that makes those holes, we could just simply change these dimensions by half an inch and nothing will break. However, it may be faster to simply do a linear pattern on the holes, use fully defined sketch, and delete the previous holes, so that's what we'll do here. We tell SolidWorks to add new holes half an inch down. Now we delete the previous holes. To finish up, we'll fully define the sketch from similar edges as it was defined from before. Now let's go back to the main assembly and rebuild. Notice that we have several broken mates, and because the holes aren't in the same location, auto repair mates may not even work. We could have done something better. Back when we were deleting the previous holes, instead of deleting them, we could use the replace entity command. We can get to the Replace Entity command through the menu, or by selecting Replace Entity in the Confirm Delete dialog as I did here. This updates all previous references to that sketch entity and the things it would create to some new sketch entity. This works perfectly for our case. We can choose to either delete the old sketch entity at this point or simply turn it into construction geometry. Now that we have done Replace Entity to all of these holes, we return to the main assembly again. Notice now, because of this procedure, no mates needed to be repaired. Next best practice is to use more subassemblies. Ideally, you would try to minimize the amount of new parts inside of an assembly and use a subassembly instead. That's mostly because of mates. We've discussed how each time an assembly rebuilds, and it does often, it will recalculate each mate. If there are a lot of parts and mates in an assembly, that's a lot of rebuilding time. With exception to a flexible assembly, a subassembly will have all of their mates contained within that subassembly and comes into the main assembly as a fixed collection of geometry, so they don't need to be calculated. So this is a good recommendation for performance, but where it helps us where we're concerned with repairing mates is if we have a set of stuff that is repeated for an assembly. If one of those components breaks its mates, you just have to repair it in that one subassembly and it will solve all of the problems in the main assembly. A good example of this is the hinge in our grill assembly. There are 2 hinges in this grill assembly, so this would be a perfect opportunity to make it into a subassembly. I'm going to drag a box around the hinge and all the toolbox components, and I can choose to Form New Subassembly in the menu that appears when I right-click on one of the selected components in the design tree. This takes all of these components and any mates that refer only to any of the selected components and sends them to the new subassembly. Otherwise, any mate that refers to a component of the subassembly and something outside of the selection set will remain in this main assembly so the hinge stays in place. Let's rename this subassembly hinge, the same way we would rename a feature on a part. Now that our subassembly is complete, we need to go about replacing the other hinge with this new subassembly. Once we've done that, we need to show that this grill lid can open. To make that possible, we need to make our subassemblies flexible. We can do that by selecting this command from the pop-up when you select the subassembly in the design tree. Now we need to test to make sure this lid moves. This new subassembly has been automatically saved internal to this assembly, but we want to save it externally with its own file name. I'm going to right-click on the subassembly and save just the subassembly externally in the same folder that the main assembly is located in. We have now been told that we need to change one of the holes for the screws to be a 1/4 inch slot. Let's go ahead and make that change, and for the sake of the example, let's neglect using replace entities and simply make the original circle construction geometry. Now when we return to the main assembly, we see that both of the subassemblies have failed mates. Because this is a slot instead of a hole, we will now go into the mates folder and delete the old mate. We will instead replace it with a mechanical slot mate to take advantage of the fact that we are using a slot for our fastener. And because we have made this a subassembly, we only had to make that change once, and it has been applied to both hinges. This one might seem somewhat common sense, but I have found that subassemblies are not often utilized to their full potential. Lastly, let's briefly discuss using assembly mirrors and patterns. As far as mates are concerned, the use case for this is much like using subassemblies. When a mate breaks on a part that has been patterned or mirrored, you just need to fix the mates on that one seed part, and all pattern parts will not need changing unless the mirror or pattern condition become invalid. To show off patterns, the part of the grill that makes a lot of sense to look at is the support frame at the end. Here we have many plastic slats that are placed along the frame. In this example, we need to remove the countersink from the plastic plank holes. When we do that and return to the subassembly, we see that each of the plastic planks had mates that failed. If this subassembly was constructed better, we wouldn't need to repair all of these mates, just one. To improve this assembly, I'm going to delete all but one of the plastic planks and use a pattern to create the other planks instead. I'll use a pattern-driven pattern because the holes the planks line up with were created with a pattern that we wish to match. Now I just have to fix this one mate, and the rest of the planks are fixed as well. Following all of these best practices combined with the new auto repair mates tool will make spending hours fixing mates in an assembly far less common, if not a thing of the past. Thank you for your participation in this session of 3D Experience World 2023. I hope you came away with a greater understanding of the new auto repair mates feature that will save you a ton of time. Bye for now.